Increasing and decreasing function, differentiation, unit 7. First of all, we talk about gradient. Gradient is also called slope, the slope of a line, how steep the line is. Sometimes it's referred to as m in y equals mx plus c, equation of a straight line, where m is the gradient, c is the intercept on the y-axis. Tangent theta. When a line inclines at an angle theta, the tangent of that angle is opposite over adjacent. This is the hypotenuse, and that's opposite over adjacent, dy dx. And dy dx is also called gradient. So tangent of an angle is also the gradient of that angle. And it's also referred to as f dash x when fx equals y. Y dot or y dash, these are all referred to as gradients. There are 4 types of gradients that we need to know. The first one is the positive slope. So that's a positive slope, that's a positive gradient. The second one is negative slope coming down the hill. This is negative, m is negative. And the third one is m equals to 0, horizontal, when you're driving along on a horizontal line. And the fourth one is where m equals infinity. That means on a vertical line, it's difficult to climb a vertical wall. So those are the 4 types of gradients. An increasing function is a function with a positive gradient where dy dx is greater than 0. So that will be an increasing function. A decreasing function is a function with negative gradient where dy dx is less than 0. So that's a decreasing function. A stationary function is the one where dy dx equal to 0. In this case, that's stationary. So this is increasing function, decreasing function, stationary function, and an infinity gradient. Looking at 2 graphs here, so if I just do these 2 graphs, and an increasing function is a function that goes like that. The gradient on this function, you have to draw a tangent to a point, and these tangent points are changing every time because it's a variable gradient. That means the gradients are changing. So that's a tangent here. That's the gradient here. You can see it's positive. Similar. Tangent, 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 tangent. A tangent is a gradient, right? That's a tangent. So this is a tangent because you can find the gradient there. So you can find the gradient. That's the angle tangent. So it's a tangent. Again, you can find the gradient. That's the angle there. So you can see these are all positive gradient. So that's an increasing function. If I draw a line going there like that, okay, so you can see there's a tangent there too. Tangent. So tangent. So again, that's an increasing function. This is y. That's the x-axis. In this function here, dy dx is greater than 0. So that's an increasing function. On the other hand, if you have a graph where the function is coming down like that, and we picked a point because we have to draw a tangent, you can see as we picked a point, each point will have a different gradient. So that will be tangent. You can see it's negative, and if you draw that, there's still a gradient there. Each point has its own gradient. So that's a tangent. And you can see that's a negative gradient because that's negative. The line is negative. Therefore, with dy dx, that will be less than 0. And another type of decreasing function is when the function is coming down like that. That's negative gradient there, negative, negative. And if you draw a tangent, you can see it's negative, negative, negative. Just remember this is x and this is y. So increasing function, so that's increasing function. and decreasing function. So that's the difference between increasing function and decreasing function. When we have an example, y equals 2 minus 9x squared, I'm going to determine which part is positive gradient and which part is negative gradient. So which part is increasing function and which part is decreasing function. Two ways you can solve this problem. One way is to differentiate. So you can say y dot, which means the y, the x, or y dash, same thing, or f of x dash. And that can be, if you're differentiating for a function y equals x to the power of n, then the y dx has to be n x to the power n minus 1. Has to be in that format, x to the power of n. Now, 2 to the power of 2 times x to the power of 0 is 2, because x to the power of 0 is x to the power of 0 equals 1. So even though the constant 2, so therefore we can use that to differentiate. So xn, n is 0. 0 times 2, you can see that's 0 already. So that's gone. Minus n is 2. 2 times 9, 18. Then 2 minus 1, x to the power 1. Therefore, the y, the x, equals minus 18x. So what value of x can I put in here? So if I have, and starting here, 0, that's an x-axis here. So this side of x-axis is x greater than 0. This side here is x less than 0. When x is less than 0, that means negative. If I put negative here, negative times minus 18 will be plus. So therefore, the y dx is positive. So that's increasing function. So this side here is the increasing function. When x greater than 0, that's positive. If I put positive value here, I'm going to get negative. So the y dx is negative. This side is decreasing. So this side is decreasing function, and this side is increasing function. And that's what the question is asking. So which side is increasing? When x is less than 0 is an increasing function. Which side is decreasing? When x is greater than 0. What happens when x is 0? Well, if I put 0 here, I'll get 0. That's stationary. So when it's 0, it's stationary. So at 0 here, we get stationary. Increasing function to stationary, 0, and then to decreasing function. Why don't we try and sketch it to see what we're talking about? To sketch that graph, we have y equals 2 minus 9x squared. So we need to find the root where it crosses the x-axis. To find where it crosses the x-axis, y has to be 0. It crosses the x-axis here. This is positive y, negative y, and y is 0 here. That's the line where this line is y equal to 0. That's where the curve crosses the x-axis. That means this has to be 0. That equals to 2 minus 9x squared, which implies that 2 equals 9x squared. Therefore, x squared equals, divide both sides by 9, 2 over 9. And if we square root both sides, we get x equals plus or minus root 2 over 9, which equals plus or minus root 2 over 3, because root of 9 is 3, and that equals plus or minus 0.471, which means the point where it crosses the x-axis are these 2 points, root 2 over 3 minus root 2 over 3. And when x is 0, if you put 0 here, 0 times 9 will disappear, and then you just get y equals 2. So this is the maximum point here at 2, y equals 2. So if you sketch the graph, it's going to have a turning point here at x equals to 0. That's a turning point. And it crosses the x-axis there and there. Now we can see the gradient here, because the gradient here is positive, 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 just like that. So that's when x is less than, so x is less than 0. You can see that. Here we can see gradient here is 0 because it's horizontal. That's stationary. And when it comes to here, the gradient is now negative, negative. So when x is greater than 0, the y, the x is less than 0. And here, the y, the x is greater than 0. So this is the increasing function, and that's the decreasing function.